today's topic is gravitation. In your previous class about force, we actually describe about two kind of forces. One is contact force, another one is non-contact force. Now, for the generation of any kind of forces, there should be a two-body phenomena. One is which is force applied and on the body on which force is applied. Now, if there is a physical contact between the two bodies, then this force is called contact force. Like tension force, push, pull, both are contact forces, because for this kind of forces we have to actually require a physical contact between the two bodies. Now, if the force doesn't require any materialistic medium, that does require a materialistic medium, but there is no physical contact between the two bodies, then this kind of forces are said to be non-contact forces, like gravitational force, magnetic force. Now, we deal with a special topic which is called gravitational force, and the branch in which the gravitational force and its consequences is dealt, that branch is called the gravitation. Now, what is gravitation and what is the law of gravitation? In this case, there are famous law of scientist Einstein Newton's gravitational law. Actually, this law is formulated long ago. Now, what is gravitation? This is the prime concept. Say these are the two bodies having mass m1 and m2. So, there are two bodies having mass m1 and m2. What is mass? We know that very well, but for simplicity, the mass is the amount of substance present in a body. Now, if the two masses are at a distance r, that means the two masses are situated with a difference of r. Now, the gravitational law or the law of gravitation or simply the gravitation or gravitational force is actually the attractional force between the two bodies wherever the body is positioned. If the body is in earth and one of the body is in the Mars, then these two body also attract each other. So it is a attractional force, always attractional force, whether the two bodies situated. Now, if this is the attractive force, so gravitational force is defined as the attractional force between the two bodies having a definite mass. Now, there are famous law of gravitation which given by the famous scientist Newton. So, what is the Newton's law of gravitation? Now, as there is a force, that force is a vector quantity, that means it requires a magnitude as well as its direction. So, if we consider only the magnitude of the gravitational force and symbols by F, then this gravitational force F gravity or F gravitational, by that principle of gravitation, is directly proportional to the product of their masses. The two bodies having mass m1 and m2, that's why the gravitational force is directly proportional to the product of their masses. So if we increase the mass of the two bodies, that means the gravitational force also increased. Now, and it is directly or not directly, it is inversely proportional to the square of the distance, intermediate distance between the two masses, and that distance should be the straight line or the minimum distance between the two bodies. As the force is a vectorial quantity, so we have require a particular direction, and that direction is the smallest distance between the two masses. Whether the body's position is, we have to require a smallest distance between the two bodies, and that distance squared is inversely proportional to the gravitational force. That means if we increase the distance between the two bodies, the gravitational force will also decrease. So by that two form, we can actually write if gravitational is proportional to m1 m2 by r square. This famous law actually derived from that equation of proportionality. If A is a common quantity which is directly proportional to B and similarly A is directly proportional to C, then this A should be directly varies with the product of B and C quantities. So B is nothing but the M1 and M2 and C is our 1 by R square. So F is directly proportional to M1 M2 by R square. Now from that proportionality relation we have to conclude a directly proportionality constant. So from here the gravitational constant is derived as follows. F gravitational that should be equal to G M1 M2 by R square. What is G? G is called universal gravitational constant. G is called universal gravitational constant. What is universal gravitational constant? Let's define the universal gravitational constant. The two bodies having unit mass and they are at a distance of unit distance, then the amount of force on the two bodies is said to be the universal gravitational constant. So it is the fixed value, that's why it is called a constant quantity. And why it is called universal? Because in the universe, in every position of the universe, that G, the value of G should be remain constant. No condition can vary that the value of G. But recent discoveries regarding the black holes and etc. This question arises: is it a constant or not? So it is a different part of a syllabus. Now, so this is the gravitational constant which is symbolized by the capital G, and the value of capital G is written as, by series of experiment, it is found that the value of G that should be equal to 6.67 into 10 to the power minus 11. Now we have required the unit of that gravitational force constant or gravitational constant. Now how we identify the gravitational unit of gravitational constant? Say F equal to G M1 M2 by R square. So F, the unit of F is Newton, and the value or the unit of G we have to derive. So the value of masses, that means M1 and M2, is nothing but kg into kg by the R square. R is the unit of length, so R square corresponds to meter square. So the unit of G is like that, Newton meter square per kg to the power 2. So this is the unit of G. So what is the unit of G? Unit of G is Newton meter square per kg to the power 2. So writing down this Newton meter square kg to the power 2. So this is the unit as well as the value of G, which is 6.67 into 10 to the power minus 11 Newton meter square per kg to the power 2.